Alright, 46. It says round to the 1,000th place. Well, that's going to be a decimal. I mean a calculator. 46. 7 equals 8 times e raised to the x minus 1 power. Alright, what do we do first? First step. Divide by 8, very good. So 0.875 is equal to e raised to the x minus 1 power.
You take the natural log of both sides, right?
Yep. And now we'll take the natural log of both sides. So natural log. This becomes negative 0.1335. These cancel out, so I'm just left with x minus 1. And then we add 1 to both sides. So x is equal to 0.8 tens, hundreds, thousands. 0.866. Questions on 46? All right, 47. All right, use the formula to find the number of years it would take to double. $600, 4% APR compounded annually, round to the nearest tenth of a year. All right. So where's the 600 go?
600 goes for P.
P. What about 4% is our rate, right?
Yeah.
But we gotta turn it into a decimal, so it'll be 0.04. What is N?
Oh, it's how often it's compounded, right?
It's how many times a year it is compounded. It's compounded annually. So N in this case is gonna be 1.
Yeah.
We're looking for T, right?
Yeah.
Use a formula, find the number of years. So T is our variable.
And then A is 1200.
A is 1200.
Yeah.
How'd you get that?
Oh, because it said double $600.
Good. Any questions on any of that? All right, what should we do? Divide by 600. So on the left-hand side, I got 2. I can go ahead and combine this, right? 1.04 to the t power. Now what? Our variable is exponent. That's what logs are for. So put it in logarithmic form. So we're going to move, this is our base right now of the power. We're going to move it over and keep it a base, but we're going to bring in the log. So it'll be log base 1.04 of 2 is equal to t. And then some of you cannot plug this right into your calculator like this because your calculator only does base 10. So we need to do change of base. So it'll be log of 2 divided by log of 1.04. So that would be 17, what did it say, round what? Round to the nearest tenth. So 17.7 years. 25% chance of getting this question right if you forget your calculator on exam day, right? Unless you include E as an answer choice. Don't put E on the exam. All right. Any questions on 47 before we move on? Okay. 48. Use the formula 8. To find the amount of money in the bank at 4.25% interest compounded quarterly for 12 years if $1,200 was put in the bank originally, round to the nearest penny. So $1,200 principal, 0.0425 is our rate, compounded quarterly, so 4 times a year, 4, and then for how long? 12 years?
Yeah, so probably.
So this we're just plugging in our calculator, right?
Mm-hmm.
I got 1992. Anybody remember that year? Only one person in this room. Does it say round to the nearest penny? Any questions? Everybody okay with getting $1,992.98 on their calculator?
Yeah.
Okay. 49. Moving along. Give the inverse of that and tell the domain and range of the inverse. Okay. Okay, let's do the domain and range of this first. What's the domain of this function?
All real numbers.
It's all real numbers, right? Is there any restrictions? Can't I do 2 to a negative number?
Yeah.
I can do 2 to 0, right?
Mm-hmm.
And obviously 2 to a positive number. So the domain is all real numbers. What's the range?
Anything above 0.
Anything greater than 0, right?
Yeah.
No matter what I plug in here, I can't get a negative for an answer. 2 to the negative 2 power is 1/4, right? So the range, y is greater than 0. Remember, this is exponential growth. A quick sketch of it would look like this, right? We have a horizontal asymptote. You approach it but never cross over it. Okay? Alright, so let's find the inverse now. What's step 1 to find the inverse of a function?
Switch the x's and y's.
Switch the x's and the y's. And remember we said this is equal to y. So if we switch the x's and y's, we'll have x equals 2 to the y power. And step 2 is to solve for y. How am I going to get that y by itself?
When you square, I'm gonna take the square root of.
It's not y squared. Yes?
Could you multiply both sides by e and do the natural log of both sides?
Multiply by e and take the natural log of both sides?
Yeah. Oh wait, no, that's never mind.
Where's the variable we're trying to solve for? It's an exponent.
Oh, put it.
Put it in logarithmic form, right? This is the base, move it over, so it'll be log base 2 of x is equal to y.
Yeah.
So the inverse of f of x is equal to log base 2 of x. Okay, so now we need domain and range. What's the domain of this? This might be the easiest question all day.
It should be all range, yeah.
The domain x has to be greater than 0, and range, all real numbers. Notice the domain and range switched. Just like we switched the x's and y's. Any questions? All right, 50. In behavior. All right, so what do we need to determine the end behavior? Or what determines the end behavior?
The degree of the function.
The degree of the polynomial, the highest exponent. What else also determines the end behavior?
Positive and negative here.
The leading coefficient, right? Positive number in the front or negative number in the front. Okay, so these are not in standard form. What's the degree of equation 1?
4.
It's going to be degree 4, right? And is my leading coefficient going to be positive or negative?
Positive.
It's going to be positive 1, right? So degree 4 with a positive leading coefficient, what's the end behavior going to look like?
Should be just
Up and up, right? So as x approaches positive or negative infinity, the y value is going to approach infinity, right? What the heck are we supposed to do? We're going to pick 2 of them?
I'm guessing, yeah.
So this one, as x approaches infinity, y will approach infinity, and as x approaches negative infinity, y approaches also positive infinity. So this looks like A and C. All right, the next one, the degree is what?
3.
It's going to be degree 3, but my A value is going to be a negative, right? So it's going to behave a lot like a linear function, right? With a negative slope. So what's the end behavior? Well, you guys do this way. So as x approaches infinity, y would approach what? Negative infinity, right? And as x approaches negative infinity, y would approach positive infinity. So that would be B and C.
Yeah.
All right, equation 3. What's the degree going to be?
3.
All right, we've got x plus 3 squared and x minus 1. Degree is going to be 3. And my A value is going to be a positive, right? All right, so it's an odd degree. It's going to behave a lot like a linear function with a positive slope. So my end behavior will look like that. So as x approaches infinity, the y value is going to approach infinity. And as x goes to negative infinity, the y value is also going to go to negative infinity. So that's going to be A and D. A and D. And then finally, the last one, equation 4, negative 2x minus 3 squared x plus 1 squared. Degree is 4, even degree. So it's going to behave a lot like a quadratic with my a value is a negative 2. So it's actually going to be down and down like that. Because an a value of negative will reflect it across the x-axis. So as x approaches infinity, my y value is going to approach negative infinity. And as x approaches negative infinity, my y value is going to approach negative infinity. So that would be B and D. Questions on 50? Okay.